My name is Mike Sori. I'm an assistant professor at Purdue University. Yeah, so Uranus is what we call an ice giant. It is a large planet 2 billion miles away from the sun, so about 20 times more distant than Earth. It's about 4 times the diameter of Earth, about 15 times as massive. And planetary scientists have ranked a mission to Uranus as one of as the highest priority mission, flagship mission to be initiated in the next decade. So Uranus has 27 moons that we know of, 13 rings, and this mission would orbit Uranus for several years and study the host planet, the rings, the moons, and see what we can learn. Yeah, so ice giants are their own class of planets. So in the solar system, we have the rocky planets, Mercury, Venus, Earth, and Mars. We have the gas giants, Jupiter and Saturn, and then we have the ice giants, Uranus and Neptune. So Uranus and Neptune are actually different than Jupiter and Saturn. Jupiter and Saturn are mostly made of hydrogen and helium. Uranus and Neptune, the ice giants, have a higher proportion of things like water, ammonia, methane, ices. So they're really their own class of planets. And they're the one kind of planet that we haven't explored yet in detail with an orbiter. We've flown by Uranus and Neptune in 1986 and 1989 with the Voyager 2 spacecraft, but we haven't orbited either planet for years in the same way that we've done the other rocky planets and gas giants. So we'd really like to study Uranus as sort of the typical ice giant, to understand the context of ice giants in general. Ice giants are also, we think, one of the most common types of exoplanets, so planets orbiting other stars in the galaxy and the universe. So Uranus can sort of provide a ground truth to study exoplanets in general, which are one of the most abundant types of planets in the universe. Right, so right now the concepts are in a relatively early stage. So scientists have prioritized this idea for a Uranus orbiter to be one of the highest priority missions, the highest priority flagship mission to be initiated in the next decade. So the ideal would be to launch in something like 2031, 2032. That would yield the shortest possible flight time to Uranus. That would mean it would take about 12 or 13 years to get from Earth to Uranus. But we could launch in later years in the later part of the 2030s as well and get there just with a little bit of a longer flight time. So we'd want to orbit Uranus. We'd want the mission to orbit the planet, fly by a lot of the moons. There is not an official set of selected instruments yet, but we can speculate and imagine that instruments to accomplish the science that we want to do would include things like cameras, spectrometers of various sorts, magnetometer, maybe other instruments as well, maybe even a separate probe to go into the atmosphere of Uranus and study its atmosphere. Yeah, so Uranus is just a great place to study ice giant planets in general. So the mission most broadly would want to put Uranus in the context of ice giant systems. And there's a lot of different scientific questions to study about Uranus. So for the planet itself, questions of interest include: why is the planet tilted on its side? Why does it have so little heat coming from its interior? What does the interior look like? Is the interior divided into discrete layers, like the Earth has a crust, a mantle, and a core? Or is it something more dilute and fuzzy than that? We'd like to study its atmospheric dynamics. What does an atmosphere look like on an ice giant in general? And then we also want to study its moons a lot. So 5 of the moons in particular, Miranda, Ariel, Umbriel, Oberon, and Titania, are large enough such that they look like spheres. They look like little miniature planets in their own right. And what we'd really like to study with those is, are they ocean worlds? Do any of these large moons contain subsurface underground oceans of liquid water, like we think some of the other moons of the giant planets do? So that would be one of the big goals of the mission.